Today we are going to talk about osmosis. But what is? Okay, we can define osmosis that is the diffusion of water across a selectively permeable such as membrane. Water is passed through the membrane thanks to the concentration gradient membrane. A selectively permeable membrane is a membrane that allows water but not all the solute dissolves into the water to diffuse through the membrane. Water diffused from a solution with proportionally more water across a selectively permeable membrane, and into solution with proportionally less water. Because solution concentrations are defined in terms of solute concentrations and not in terms of water content, water diffused from the less concentrated solution into the more concentrated solution. Osmosis is important to cells because large volume change caused by the water movement disrupt normal cell functions. Osmotic pressure is the force required to prevent the movement of the water osmosis across a selective permeable membrane. The tube is immersed in distilled water. Water molecules move by osmosis through the membrane into the tube, forcing the solution to move up to the tube. As the solution rises into the tube, its case produces restrictive pressure that moves water out of the tube back into the distilled water surrounding the tube. At equilibrium, net movement of water stops, which means the moving of water out of the tube caused by the hydrostatic pressure. The osmotic pressure of solution into the tube is equal to the hydrostatic pressure that prevents the movement of the water into the tube. The osmotic pressure of solution provides information about the tendency of water to move by osmoting across a selectively permeable membrane. Because water moves from the less concentration solution into more concentrated solution, the greater the concentration of solution and the greater the osmotic pressure to prevent the movement. The greater the concentration of solution, the greater the osmotic pressure of solution, and the greater the tendency for water to move into the solution. The solution are still osmotic even if the types of solute particles in two solutions differ from each other. In one solution, what was greater concentration of the solute particles and therefore a greater osmotic pressure than another solution. The first solution is said to be hyperosmotic compared to the more dilute solution. The more dilute solution with the lower osmotic pressure is hyposmotic compared to the more concentration solution.
The additional terms describe the tendency of cell to shrink or swell when placed into a solution. If a cell is placed into a solution in which it neither shrink nor swell, the solution is said to be isotonic. If a cell is placed into a solution and water moves in the cell by osmosis, causing the cell to swell, the solution is called hypotonic. An isotonic solution may be isosmotic to the cytoplasm because isosmotic solutions can have the same concentration of solutes and water as the cytoplasm of the cell. No net movement of water occurs and the cell neither swells or shrinks. Hypertonic solution can be hyperosmotic and have a greater concentration of solute molecules and lower concentration of water than the cytoplasm of the cell. Therefore, water moves by osmosis from the cell into the hypertonic solution, causing the cell to shrink, a process called crenation. Tonic solution can be hyposmotic and have a smaller concentration of solute molecules and greater concentration of water than the cytoplasm of the cell. Therefore, water moves by osmosis into the cell, causing it to swell. If the cell swells enough, it can rupture, a process called lysis. Solution injected into the circulatory system or the tissues must be isotonic, because crenation or swelling of cells disrupt their normal function and can lead to cell death. Experiment materials: 1 fresh raw egg, vinegar, and glass. Protocol: place the egg in the glass and cover it with vinegar. 2. acidic medium dissolves the eggs, which we can verify by observing the bubbles that form. 3. Leave the egg in the vinegar for 45 hours. 4. Once the egg is completely peeled, it must be washed carefully.